We're going to take a look at as many examples as I can cram in here in 15 minutes of adding and subtracting rational expressions. So let me start by summarizing the process of this, and for time's sake I'm going to pause while I type, and then I'll start the video back up once it's all typed and we'll go through it. Okay, to add or subtract rational expressions, first thing I want to do is emphasize what our ultimate goal is here when we add or subtract fractions. Basically, we want multiple fractions to combine into a single fraction that is reduced. Okay, so keep that in mind. Our goal here is to get a single fraction as an answer. Or if it reduces enough, it may not even be a fraction in the end. So how do we get started here? The first thing we need to do, or that I really like to do, and I think it's a good tip, it's helped a lot of my students, any negative fractions, turn them into positive fractions. And you do that by shifting the negative into the numerator. Remember, a negative in a fraction can float to the numerator or to the denominator, so float it to the numerator and then the fraction becomes positive. I'll show you an example of that when we get to it. Number 2, I put 2 stars next to this because this is what most people forget to do. Factor the denominators. You want to break your denominators down to their smallest pieces before you try to add the fractions or rational expressions. And that's because if the denominators aren't the same, you have to make them the same. So you take and you multiply each fraction by an appropriate form of the number 1. These forms of 1 will look like fractions, and the goal is multiply them by a form of 1 so that each fraction will, or all the fractions will have the same denominator afterwards. Okay, so you'll see how that works. Once they all have the same denominator, you can combine the numerators over the common denominator. So you're putting all the numerators together into one numerator, and then you want to make that numerator as simple as possible, combine like terms, etc. Now you have a single fraction. At this point you have a single fraction, but we need to have a single fraction that is reduced. So the final thing we need to do is make sure to simplify or reduce the resulting fraction. And you do that by factoring and canceling if possible. Okay, let's get to some examples. So here's an example where we have one fraction minus another fraction. The first thing I'm going to do is change each of these fractions is negative. So what I'm going to do is make each of the fractions positive first by shifting the negative up to the numerator. And so when I do that, the negative applies to this entire numerator, and the other negative applies to this entire numerator. So the negative distributes, giving us negative 3x plus 7y over 4x, plus, because now this will be addition instead of subtraction, and the negative is going to shift up to here, just like it did with the first one. So this becomes plus, and I have negative 8x minus 5y over 4x. Now when you add fractions, they have to have the same denominator, and these do. So that means I'll combine those two fractions together over that common denominator, and then I'll just add my numerators. So negative 3x plus negative 8x is negative 11x. Positive 7y minus 5y is plus 2y. And then I need to see if this reduces. Right, I've combined my fractions into a single fraction. Can I simplify it? Well, in order to cancel, I would have to be able to factor. I need multiplication on top. It's not, it's subtraction. And I can't factor the top, so I'm done because I can't factor, so I can't cancel or simplify. So that's my final answer for this problem. Now here's a different problem. Again, I've got one negative fraction, one positive. So the first thing I'm going to do is make that negative fraction into a positive fraction by shifting the negative into that numerator to get negative 4c minus 1 over 5c. Now, I need to take each fraction because my denominators aren't the same, and I need to multiply each fraction by a fraction that equals 1. So this has to equal 1. And we'll figure out what's going to go there in a second. And I do the same thing for the second fraction. This has to equal 1. Okay? Now, I'm trying to turn 3c and 5c into the same thing. I'm trying to make them the same. That's called a least common denominator. What's the smallest thing that I can turn 3c into that I can also turn 5c into? Well, notice if I multiply 3c by 5, I'll get 15c. And if I multiply 5c by 3, I will also get 15c. That's the smallest thing I can turn both of these into. So my LCD, my least common denominator, is 15c. So I just want to point that out. Now, these fractions have to equal 1 because I can't change the value of this first fraction. And multiplying by 1 won't change its value. But if my denominator is 5, my numerator also has to be 5 because 5 over 5 equals 1. And the same thing over here, this has to be 3 over 3 if it equals 1. Now what I do is I just do the order of operations. I do my multiplications before I do my adding. So to multiply, I go straight across over here. So I've got 5c minus 3 times 5, which means this 5 will distribute, giving us 15c minus, or sorry, 25c minus 15, all over 15c. Plus, my second fraction, multiplying my numerators, gives me negative 12c minus 3 over 15c. Now notice, my fractions have the common denominator on the bottom, 15c. Now that the denominators are the same, I'll combine the two fractions into a single fraction with that denominator. Right, when you add, the denominator stays the same. So I have 25c plus negative 12c, which is 13c. Negative 15 minus 3 is negative 18. I can't factor anything here to cancel, so I'm done. So there's a simple example where the denominators are not the same. Okay, again we have a negative fraction, so the first thing I will do is make it a positive fraction by shifting my negative into the numerator, making it negative x plus 1. Now I look at my denominators. They won't factor. I can't factor either one, so I have to try to figure out how to make those denominators the same. So I'll multiply each fraction by a form of 1. And I've got to figure out what form of 1 to use. So what can I turn 6x minus 7 and 8x into? And that's tricky the first time you see it. Well, 8x times 6x minus 7. This is the smallest thing that I can turn these both into. And I'm doing it by multiplication, right? Whatever I'm putting here is going to multiply by 6x minus 7. So the only thing I could put there will be 8x. Because if I put 8x there, my denominator for this first fraction will be the least common denominator. And over here, I need 6x minus 7. But then each red fraction individually has to equal 1. So the first one's 8x over 8x, and the second one is 6x minus 7 over 6x minus 7. Then I do my order of operations, and I multiply before I add. So I'll multiply the first two fractions together and the second two fractions together. So x times 8x is 8x squared. On bottom, I'm not going to distribute the 8x. Right? On the top, I'm trying to get a new numerator to combine with this numerator. And in order to combine those, I have to multiply first. My denominators I'm not combining. I'm leaving that alone. I just need them to be the same. So I'm not going to do any extra work on the bottom. That might be something you want to rewind and write down for yourself. Okay? So on the top here, I've got a binomial times a binomial. That means I have to FOIL or distribute. So I'll distribute my negative x to get negative 6x squared plus 7x plus 6x minus 7. Okay? And now my denominators match, right? So hopefully you can see why this green thing, the 8x times the 6x minus 7, why I had to use that for my LCD. So now I'm going to add these fractions together because they have the same denominator. So I'll get a fraction with that denominator. And my numerator will be my previous numerators added together. So 8x squared plus negative 6x squared is 2x squared. And then 7x plus 6x is 13x. And then I've got minus 7. So now I've got my single fraction here. I need to see if it reduces. So I'd have to factor my numerator. And I would do that maybe by splitting the middle term and using grouping or whatever technique you want to use. The numerator here does factor. I'm going to leave out the details of how to factor it. I'm assuming you know how already. So I'll write out what you get when you do factor. Let's see here. You'll have a 2x and an x. You'll have a 1 and a 7, a plus and a minus. So that's what you get on top if you were to factor. And on bottom, we still have this. Now you see, what we're trying to do is cancel, right? Because we've combined our fractions, so we need to reduce this or cancel. In order to cancel, I need multiplication on the bottom and on the top. Notice that if I would have distributed my 8x on the bottom, I wouldn't have multiplication, right? The parentheses would go away. So that's another reason I didn't distribute on the bottom. On the top up here, I had to combine these numerators together to get my new numerator, and then try to factor it like I did here. So it is factored, but there are no common factors from the top to the bottom, so I can't cancel, and this is my final answer. Okay, I may have to pause and leave out some writing here, but I'll explain this problem completely. The first thing I'm going to do is shift this negative and factor my denominators. And I'll write the second denominator in descending order first. So my first denominator is factored. I've shifted this negative up to the numerator, and 5 minus x I've written in descending order. And I can see now that I need to factor a negative 1 out there. So I factored my negative 1 out, and now I need to, we don't like the negatives in the denominator, so I'm going to shift this negative up to the numerator, which would make that a positive 2. Okay, so lots of things happening there with negatives. Make sure to rewind and take extra notes and things if you need to. Alright, now my denominators don't match, so I'm going to set up where I multiply each fraction by a form of 1. So I need to ask what I can turn x plus 4 times x minus 5 into, and what can I turn x minus 5 into. Well, I can turn x minus 5 into x minus 5 times x plus 4, which is exactly what this first denominator is. So the first fraction, I'm just going to multiply by 1 over 1. I don't need to make any changes because it's got the denominator that I want. My second fraction needs to be multiplied by x plus 4 times x plus 4 so that its denominator will match. Now I'll do my order of operations, and I'll multiply the first two fractions, and I'll multiply the second two fractions. Note that I distributed my 2 here when I multiplied those numerators. Now my denominators match. They're exactly the same thing, so they'll combine, these two fractions will combine to have one fraction with that denominator. And I just need to combine my numerators. So x plus 2x is 3x. And negative 23 plus 8 is negative 15. Finally, I need to try to reduce this fraction by canceling, and in order to cancel, I need to create multiplication on the top. I do that by factoring out a 3. And now we can see that I do have a common factor of x minus 5 that will cancel, leaving me with my final answer of 3 over x plus 4. So this was a very good example. We had a lot going on. We had to shift the negative, factor. We had to factor a negative out on bottom because of descending order, shift that negative to the top, and then get a common denominator of our two fractions, put them together, and then factor the new numerator to get the fraction to reduce. And there are several examples of how to add and subtract fractions.